10 days ago, Ubiquiti updated the network controller. There's one interesting feature released. It is for packet capturing. Unfortunately, a much more exciting thing was released right after that, so I didn't have time to try that capturing feature. However, after hours and hours of fightings, I want to take a rest. So in this video, let me try the packet capturing feature in UniFi AP. In my lab environment, I have multiple types of recent UniFi access points. All of them are listed in the UniFi's release notes about what access points are supported. However, if I go to the device settings, for example, this U6 mesh, no packet capturing, U6 Pro, no, U7 Pro Max, yes, even U6 Enterprise and U6 Enterprise IW, I don't see the packet capturing. So in this video, I'm only going to show you the U7 Pro Max for packet capturing testing. You may be familiar with capturing Ethernet frames using Wireshark in your local network, but the Wi-Fi frame capturing is very different because you want to see the 802.11 frame information instead of TCP/IP information. That's one complexity. The other thing special in the Wi-Fi frame capturing is your Wi-Fi device need to support these two special modes. The promiscuous mode basically means it can not only capture the frame which is supposed to be received by the client, but also other packets, even though they are not targeted to this client. And for monitor mode, it will go even further. It will capture not only the Wi-Fi frames for the access point you are on, but also other frames which are from other access points or Wi-Fi clients. This has to be enabled so that you can capture everything on the air. Capturing Wi-Fi frames is much more complicated than capturing Ethernet frames through your Ethernet cable. In my channel, in the past, I posted a video talking about different ways to capture Wi-Fi frames. Here, let me briefly mention them. The easiest way is if you have a very old Mac hardware, very old Mac OS, it works out of box. So you can directly run Wireshark, flip on the monitor mode, then you are ready to go. If you have a relatively new Mac hardware and a new Mac OS, it's not very direct. You can run the built-in sniffer to sniff the Wi-Fi frames. Then you can use Wireshark to display the captured file. So that's the way I have been using for a long time. Another approach needs some preparation, but once you have the environment set up, the capturing itself is very straightforward. So you need a Linux, then you can do some manual Wi-Fi interface configuration so that you set up a monitor interface. Then you can run Wireshark to capture the frames on the fly. All the three approaches, they work. By the way, you may know UniFi devices come with tcpdump. If you SSH to your access point, yes, you can run tcpdump, but because you don't have a Wi-Fi interface which is configured in monitor mode, you are not able to dump the wireless, the Wi-Fi frames. You can only dump the regular Ethernet TCP/IP frames. The tcpdump way didn't work in the past. Let's first see how it works in UniFi AP in action. Then we can go to the backend to understand how the packet capture is implemented in UniFi AP. So let me click on the U7 Pro Max. Here I have the packet capture button. Click on it. Okay, see here, there are several interesting observations. It can not only capture the Wi-Fi frames, but also the regular Ethernet frames through the uplink part. So the second feature was already there in the past if you want to use tcpdump. So I'm not interested in the second option. So in this video, let's focus on the wireless capturing. And the second observation is it seems at the same time you can capture the 3 different Wi-Fi bands. That's very exciting because if I use, let's say, Mac machine to capture the Wi-Fi frames, I can only pick one Wi-Fi band, not all 3 of them. This is a very great feature. Then here it has a duration setting. You may know if you use Wireshark or tcpdump, as long as you want, you can capture the frames for a super long time. Your storage is your only limitation. But here it seems it has some limitation when it comes to duration. Let me mess up with the number to see what's the lowest highest number. 1 second. Oh, disappointing. So the lowest duration is 30. How about 300? Yes, it works. 3000. Okay, so the max value is 300. It can only capture maximally 5 minutes frames. I completely understand what's the reason, because here we are talking about AP. The system has to store the captured file in the access point's local storage. Then you can move it to your local machine, right? So of course, it doesn't want your capturing occupy all the disk space. So that's understandable. Okay, let's stick to 30 seconds. Click on capture. Okay, started. Almost done. It's freezing there. I guess the system is saving the file to the storage. Okay, it's done. And here I have a button to download file. I don't have to manually grab the file from the AP. I can directly download it. Very convenient. Okay, it's downloaded. So this is the downloaded file. There are totally 7 files here. Interesting. I see 2 MON files. Just by the name, they imply they are for the monitoring Wi-Fi interface. But why only 2? I remember I chose all the 3 Wi-Fi bands, right? I expect to see 3, so I need to find out what happened later. I see 5 other files. Apparently they correspond to the Wi-Fi interface name for different Wi-Fi band. But why there are 5 of them, I also need to find it out in the access point backend. Okay, but anyway, let me pick a file just to display the content. This file is for Ethernet frame, not Wi-Fi frame, because I don't see channel information and the protocol are normal TCP IP protocols, right? And let me open the monitor file. Okay, these are the Wi-Fi frames which I am most interested in. So see the channel column. This file is for 5 GHz for sure. And what about the other monitor file? Okay, this is for 6G, right? But apparently I'm missing the 2.4 GHz. It may be a defect or bug from Ubiquiti, but I need to find it out. Let me SSH to the access point. Okay, I'm in. So the command I'm going to use to display the Wi-Fi device is IW. So then, because the first file has the name ATH0, I know ATH0 is a Wi-Fi interface name, but we need to find out it is for what SSID. So here I say ATH0 infer. Okay, it turns out this is for the element adoption SSID. In the upper right, you can see my current Wi-Fi network setting. I only have 3 SSIDs enabled, each one for a different Wi-Fi band. This element something is the internal built-in SSID for element adoption, not for my custom SSID at all. Okay, so we are good with ATH0. Then let's see what's ATH2. Okay, it's for another element SSID. This time it's for 5 GHz. Then for ATH4, yeah, it's for 6 GHz element SSID. So then let's see what's ATH6. Okay, see, it is the 6 GHz SSID. You can see in the upper right network controller, it is for this one, right? Then what about ATH8? Okay, it is for 5 GHz. Now I guess we don't have 2.4 GHz, maybe simply because, okay, here I don't have the U7 enabled at all for this 2.4 GHz. That makes sense. Apply changes. So later I will test the capture again. Let's see whether we can find out the missing 2.4 GHz, right? Now let me check the MON1. As I mentioned, this is for a monitor monitor interface for sure. So let me run the same command, iw dev-mon1 infer. No such device. Interesting. And for Mon2, no such device. You see the problem, right? So we downloaded the captured packets. There were two interfaces, Mon1 and Mon2 for the Wi-Fi frame capture, right? But when we check the device, we don't find them. There's a possibility that they are not here simply because the packet capturing session was already finished. So let me do the Wi-Fi capturing again to prove two things. First thing is whether we will have the 2.4 GHz files captured. Second thing is we need to find out what's the backend Mon1 and Mon2 devices. So to do that, let me go to devices, click on this AP, do a packet capturing, and because I need to check the backend settings, so I need more time, let me do a 300 seconds capturing. Start. Okay, it started. So in the same SSH session, let me run the mon1 command again. So I can feel it's very slow. The SSH is not responsive. It is also understandable because now the access point must be super busy. Okay, finally it responded. Let me run it again. Just the enter button takes time. Okay, finally, after so many times of trying, finally I got the result back. Yes, now I have a Mon1 interface and you can see the type is monitor, right? That proves our theory. It is a monitor interface, and you can see this particular interface is for 5G, and here you can see what the bandwidth is using, what's the center frequency. From what I see so far, I already know how the packet capture is implemented in the AP. So remember I mentioned if you have a Linux, you can do some preparation, set up some monitor interface, then you can use Wireshark to capture the Wi-Fi frames, right? Apparently, Ubiquiti takes the same approach. So in backend, right after you click on the start capturing button, the system will create the monitor interfaces for the different Wi-Fi bands, then use the monitoring interface to capture the Wi-Fi frames. And at the same time, it will use the existing ATH something interfaces to capture the Ethernet frames. The good thing is the AP can do all the capturing at the same time. You get both Ethernet frames and wireless frames, and you get all the Wi-Fi bands. So that's the great advantage over your manual, let's say Mac OS sniffer way, right? But you also see the side effect while the system is doing the capturing. Apparently the AP is super busy and our existing SSH session is almost not responding. Okay, so I even don't want to try to display another monitor interface. I will leave it running till it's finished. So in the UniFi controller, you can see it's almost done. I have waited for 5 minutes. The UI is still not changed. I give up. So let me stop it, then close it. So apparently the 300 seconds packet capturing caused a great trouble to the access point. Even though now you see it's showing green color, but later it will stop responding, and even from left side SSH you can see it's not connecting. It will automatically reboot and then reconnect, and the same cycle repeat. I guess maybe the previous 300 seconds capturing consumed all the disk spaces and the reboot didn't fix it, because I cannot SSH to the access point. So to resolve the issue, I have to do the factory reset to this access point. Give me some time, I will be back. Okay, I have reset the access point and I also SSH'd into it. Let me repeat the capturing, and this time let me choose all the 3 Wi-Fi bands and 30 seconds duration. Start capturing. It's successfully finished. Download the file. it still has only 2 monitor files, but it has one more ATH file. The new one is ATH7. Let me check what's ATH7 in the backend. IWDEV ATH7 info. Yeah, it is for the 2.4 GHz SSID, right? Which is good, but because we still don't have a monitoring file for 2.4 GHz, it means yes, Ubiquiti has a bug here. It doesn't have the monitoring information for 2.4 GHz, even though I already chose it in the packet capturing. Yes, the packet capture feature was just released. It may be running buggy and it may not run in a very stable way, right? I get it, but even if in the future it can run smoothly, it doesn't mean it can replace our old reliable method to capture Wi-Fi frames. The reason is the packet capture runs within the AP, which means it can only capture the Wi-Fi frames from the AP perspective. In our old way, we can move the Apple machine or the Linux machine very close to the AP. We will achieve the similar effect, right? If we want to capture the Wi-Fi frames at the AP's position. But what if your Wi-Fi client is very far away from your AP and you want to capture the Wi-Fi frames from the client perspective? In that case, the packet capturing within AP won't work because it simply won't reflect the Wi-Fi client situation. You have to use your old way, move your macOS or Linux machine closer to your Wi-Fi client and start the capturing there, right? So the new feature in the UniFi AP is a very good feature, but it won't replace our old method in all the scenarios. Before ending this video, let me try one more thing. You may know if you use macOS or Linux to capture Wi-Fi frames, when you do the capturing, you cannot use your Wi-Fi device to do the regular network activity. It may be a problem for some people, but for this UniFi AP's built-in packet capturing, let me see when it is doing the busy packet capturing, whether it can still serve the regular Wi-Fi client's activity. So on the screen in the lower left, I'm running the top command from the UniFi AP. You can see at this moment the CPU is very idle and we have enough of memory. We haven't started the packet capturing yet. From the right side, macOS as a Wi-Fi client. Let me do a iPerf3 testing. I will keep it running. You can see the speed is close to 1 gigabits. Very good. And in the left side top command, you can see it doesn't really add a lot of loads to the system, which is good. Now in the UniFi network controller, let me start capturing. I will keep it as 30 seconds. Start. Okay, it's started, and in the iPerf3 command output, you can see the speed is dramatically impacted. Now it's only 600, and in the top command side, you can see the system is a little bit busier, but not too much. It's not causing any bottleneck from the OS perspective. So then you can see the iPerf3 command remains very slow. Let's wait for the packet capturing to finish. Even though now from the iPerf3 perspective, the speed is back to normal, but the packet capturing is still not showing completed. So something's wrong in backend. Again, let me stop it, close it, and let me try again. The exact same default parameter. Start capturing. The same effect, iPerf3 is impacted. Let's keep it running. So the exact same thing happened. From iPerf3, we can see the packet capturing should be done already, but the UI still doesn't reflect any change. I cannot download the file. So I see two potential conclusions from this simple testing. First, it seems the AP has the potential to run the packet capturing and serving Wi-Fi clients at the same time, even though we know the Wi-Fi client's speed will be impacted, right? But at least the system can do the two things in parallel, which is good. The second observation is the current packet capturing implementation is too buggy. It's just hit and miss, and it's not in its prime time yet. Okay, I hope Ubiquiti can make it more stable. Okay, thanks for watching.